just like to tell you about the previous example that you just saw. There were two aspects of linear motion that were demonstrated in this. One was velocity and the other was displacement. Jake's velocity in this example was figured by dividing the distance, which is 10 meters, by the time, which was 6 seconds. His velocity was 1.66 meters per second. His displacement was 10 meters. And displacement is how far you move from the starting point. So if Jake were to go to the end of the court and then back, his displacement would be 0. But since he stopped halfway, his displacement was 10. There was also a demonstration of work in this example, and work is the amount of force that is required to move an object, and this is measured in joules. Jake's work for moving the basketball was figured by multiplying his mass in kilograms by gravity and then multiplying that by the distance. And the final product is 310.8 joules. So Jake used 310.8 joules to move the basketball.
This example shows the relative velocity between two runners going after a ball.
In the previous example, two runners were shown going after a ball. The example of relative velocity can be shown using an equation and many components.
If asked the question, how much time is between the two runners when runner A reaches the ball, a diagram is first drawn to help solve the problem. Jake started 6 meters away and Delaney started 5 meters away from the ball. Jake's velocity was 2 meters per second. This was found by dividing the distance he traveled by the time it took him to travel a given distance. Delaney's velocity was found the same way to find that her velocity was 5 meters per second. The relative velocity of the two runners is found by subtracting the velocity of runner A, Jake, by the velocity of runner B, Delaney. This is shown by subtracting 1 meter per second from 2 meters per second to get 1 meter per second. To find how much time was in between when Jake reached the ball to when Delaney would have reached the ball, an equation of velocity would be set up. 1 meter per second is equal to 1 meter, the distance that the runners started apart, divided by x for time, t for time. This simple equation is solved to find that Jake reached one point of the ball 1 second before Delaney would have.
These next two examples show projectile motion. A player tosses the ball to another player, and thus a projectile with vertical and horizontal components is present.
This video demonstrates collision. In this example, rotational motion is being shown as the ball spins backwards on its axis. Newton's first law of motion says that an object in motion stays in motion and an object at rest stays at rest unless acted upon by an outside force. In this example, the ball is moving when a player puts a force on the ball and only stops when another player catches it.
Slow down!